Okay, so today we are going to talk about circular motion, and this is lesson 2 of A-level physics. So we're actually going to talk about what is meant by angular velocity and linear speed. So before you can understand angular velocity, there's a couple of things that you need to understand beforehand. Okay, so let's have a look at this. So what is the difference between speed and velocity? Okay, so remember, speed is a scalar quantity, meaning it has size only, and velocity is a vector quantity, meaning it has size and direction. Okay, so for example, if you're talking about speed, you can say a car is moving at 60 kilometers per hour, but if you're talking about what that car's velocity is, that means it's traveling at 60 kilometers per hour in, let's say, for example, the east direction. Yeah. So, okay, cool. So, yeah, let's move on then. What about circular motion? So, like, what is the distinction between speed and velocity in terms of circular motion? All right, okay. So this is a little bit of a tricky thing to understand, is that when an object, when it's moving in a circular path, then yeah, it might look like that its speed is constant, but actually because it's changing direction, what that means is that its velocity is actually changing. So we actually say that it's accelerating. So it's a tricky thing to grasp. So even though it appears like the object is moving at a constant speed, because it's constantly changing directions, that means its velocity is changing. So we actually say that the object is accelerating. Okay, so going back to that scalar and vector quantity stuff. So this is just a key point I want to get across. This is just a convention. This is just a convention. Usually, if things are traveling to the left, usually they're given like a minus value, or usually things that are traveling to the right are given a positive value. But it can be the other way around as well. It doesn't really matter. To be honest with you, it's up to you. Okay, cool. So before you can understand what's meant by angular velocity, you've got to understand what's meant by angular speed. Okay, so it's not too difficult. So just remember that when an object, when it's moving in a circular path, it's changing angles. Yeah. So if you have a look at this little ball, as it's moving around, I mean, if once it comes up to the right-hand side of the circle, it's just moved a 90-degree angle, right? And if it keeps going, it's just moved up to 180 degrees angle. So angular speed is just how um it's just basically how much angle is covered per second, right? And when we're talking about uniform circular motion, angles they're measured in radians. Okay, so it's basically how many radians are covered per second. Okay, so this is what we mean when we talk about angular speed. All right. Okay, cool. So all right, let's move on. Okay, um, so even though velocity is changing, meaning the object is accelerating, the speed of the object can actually be constant. Yeah? So that means angular speed can also be constant as well. All right. Okay, cool. So we don't say that angular speed is like velocity and that it's changing. Okay, angular speed can also be constant as well. Okay, now let's have a look at angular velocity. Okay, so remember speed is a scalar quantity and velocity is a vector quantity. So when we're talking about angular velocity, to be honest with you, these terms are quite interchangeable, speed and velocity. But this is where we take into account whether it's moving in a clockwise direction or anti-clockwise direction. Yeah? Okay, great. But the terms are interchangeable. So basically angular speed is just a scalar quantity, angular velocity is just a vector quantity. All right? Okay, great. Now let's have a quick look at these equations. So the equations for angular speed, or you can also say angular velocity, are omega equals delta theta over delta t. And there's another one where omega equals 2 pi over t, and where omega equals 2 pi f. Okay, so just try to remember these equations, all right? So as I mentioned before, when we're talking about angular velocity, you have to take in direction into account. So when we're talking about circular motion, that means it's either going to be an anti-clockwise direction or a clockwise direction, yeah? So usually a clockwise rotation is given a negative value and anti-clockwise rotation is given a positive value. Yeah. Sorry, I think I just need to change that part here. It's given right. Okay, so now coming back to angular velocity. So as I said before, when we're talking about velocity, direction is also taken into account. So when an object is moving in a circular path, that means it's either going to be clockwise or anti-clockwise. So usually a clockwise rotation is given a negative value and an anti-clockwise rotation is given a positive value. So in engineering, it's actually the opposite, but it doesn't actually matter which one you choose. Either one is fine. So yeah. So it's up to you. Cool. So now let's have a quick look at linear speed. Yeah. So now linear speed is just basically the rate at which an object covers distance along a path. So basically that's where we're talking about the circumference of the circle. How much of that circumference has the object covered per second? So it's literally how fast that object is moving within that circular path. So kind of exactly like speed, just regular speed. Not too difficult to understand, so it should be okay. But there are some key points that you need to remember. So angular speed or velocity remains constant in uniform circular motion. Linear speed is dependent on the radius. So now it's a little bit tricky getting your head around the difference between angular speed and linear speed. So the reason why it's we take into account angular speed and not just linear speed is that if you have a look at this clock face, if you are closer to the center of the clock, you move more slowly. But the tip of the clock hand, moves faster. So you can think of it as a Ferris wheel. If you're on the outer part of the Ferris wheel, you're actually moving faster. But if you're closer to the center, you're actually moving slower in terms of your linear speed. Okay, so it's dependent on radius. Okay, but angular velocity, or you can say angular speed, remains constant in uniform circular motion because it's just a measure of how many angles are covered per second, how fast you're moving in terms of the angles that you're covering. Okay, cool. And lastly, we just need to go through the equation for linear speed. So the equation for linear speed is V equals RW. It means velocity equals radius times by angular speed, or you can say angular velocity. Okay, so cool. And that is the video for today. Thank you.